Hello FileMaker developers and welcome to Claris Engage 2020. My name is Stathis Askaridis and today I will be talking about my favorite topic, Audit Log and Transactional Operations. In this session, I will demonstrate a plug-and-play save cancel functionality leveraging only FileMaker's built-in transactional operations. I live in Thessaloniki, Greece and I'm a senior consultant at SICOA. I started my FileMaker career as a client. At that point, I was running my family business, a multinational fashion retail wholesale. I studied accounting and mastered in auditing. Last year, I was a keynote speaker at FileMaker DevCon Istanbul. I'm a FileMaker certified developer from version 16 to 18, and my favorite hobby is snowboarding. By the end of this session, I would like you to feel enlightened on data operations and keeping track of them. Finally, my favorite quote, information is not knowledge. This session will cover the basics on creating and editing records in transactional manner. It will also demonstrate an audit log implementation leveraging FileMaker's built-in transactional operations. In specific, I will showcase how to break down the record data entry process into events, enrich script steps by creating global scope scripts, deliver easily user-friendly transactional editing in existing layouts, discuss Audit Log Schema and its applications, and finally, implement Audit Log with Rollback functionality. So, let's start with the basics. What is FileMaker Transactional Operations? It comes down to three key things: committing a record, reverting a record, and record locking. Record commit is the equivalent of what the user expects to happen when saving. In specific, when user edits a record and commit occurs, the user exits that record, which means other users can now edit that record. Field data are updated, which means other users can now view the data the user entered. No field is active. These operations are commonly known as save. On the other hand, revert record is the expected behavior of a cancel operation. When reverting a record, FileMaker returns it in its state before the editing began. FileMaker will also return the state to any edits in related records. This aspect of the revert script step is what makes it so powerful in contrast to manually scripting a revert process. Those operations are what makes this script step feel like a cancel operation. Finally, record locking is the mechanism that ensures two or more people are not editing the same record at the same time. When user edits the current record, FileMaker puts a lock on it, preventing other users or even the same user to edit that record. In any given moment, a record can be edited in one occasion. When user edits a related record, FileMaker locks it, but will also lock the active record. And this is what record locking is all about. The most important functions that can help visualize those underlying operations being performed within FileMaker are the getRecordOpenState, the getRecordOpenCount, and the getModified fields. So, let's launch FileMaker and see those operations in action. We'll download the FileMaker solution template Job Tracking. To download, go to marketplace.claris.com and down below you can search the Job Tracking template. You can download this solution for free by clicking on the Download button. When download is complete, unzip the file and launch it. First, I will add some security password in order to upload the file on FileMaker server. Changing the password for admin, and then I will create a simple user. I will click OK and upload the file on the server. Say you want to create a new staff record. You navigate to the staff layout, staff details, and click on New Record. Let's enter some data. John Smith, designer, and say that while you enter the data for this record, your connection drops off. What would you expect to happen for that record? Would you expect that the record was written in the database? Or would you expect that it was never written? Let's find out for ourselves. I will quit FileMaker Pro. Let's launch our job tracking solution and find out whether our record was written or not. I will launch the file, enter the credentials, and navigate to the staff layout. As you can see, there is no record under the name of John Smith. If you noticed, when editing the new record, my clicks were always hitting inside fields. This is why the record was never committed and thus never written on the database. I will now repeat the new record process by adding a new record. I will now launch the data viewer with a getRecordOpenState function. As you can see, the value of the record open state is 1. This indicates that this record is a new record that has never been committed. While entering data in the fields, the record is not getting committed. At the moment the user clicks outside the field, notice here this number, it gets committed. 0 stands for a committed record. When user edits the record again, the getRecordOpenState will return another value. As you can see, the new value is 2, which stands for an edited record that is not committed. Say the user needs to edit this record and doesn't commit it in the process. User enters a phone and an email, but always stays inside fields and thus not committing the record. Let's add some address data and let's open our data viewer to check the record's open state. As you can see, the record's open state is 2, which means a modified record that is not committed. If you noticed, starting from the phone field to the email and address, I never exited a field. This means that if I revert this record, those edits will not be committed. Let's click on the revert record and find out. I click revert and notice my edits were never committed on the record. In order to successfully construct a save-cancel process, we need to break it down into its key elements. This problem breaks down into two categories: events and operations. Edit record starts. User creates modifications without being committed. User saves or cancels. When user selects save, other operations may need to run. Operations like validate data entry, update a counter, change the status, or even create a record in another database using API. One of the great benefits of this technique is batching all operations in a single commit. This means that the whole process either fails or succeeds, and both are known states. In between, there's a gray zone of uncertainty. If something happens within this time frame, there is no certainty on what happened with the data. The downside is you need to code all operations from the current uncommitted records context. The benefits, on the other hand, are unparalleled. If user cancels or something unfortunate happens like a connection drop, it is certain that the data is intact. So the breakdown in the edit record workflow is operations that accompany a save, events that result to a record save. To solve this, I first need to explain a concept which I call globalized script steps. By this term, I mean creating scripts that enrich a FileMaker script step. For example, instead of using GoToRelatedRecord script step, you can create a script named GoToRelatedRecord. It may seem like more work to do, but you get a central location to handle operation changes like schema change or layout change. Besides using a globalized script step, additional operations can be embedded. Take this script from the template file named GoToRelatedRecord. This is a globalized script of the GoToRelatedRecord script step. The purpose of this script is to operate the same tasks when going from table A to table B and be consistent throughout the solution. As you can see here, the developer have included some additional operations to run when context is job to client or when context is job to time entry. Using this script, instead of rewriting similar script steps again and again, reduces redundancy. It also provides the opportunity to add a global operation whenever you need to go to related records. In conclusion, the point this concept makes is changing script step scope to system-wide instead of script-wide. So which script steps need to be globalized to create a system-wide transactional operation process? Those script steps are new record, delete record, commit record, revert record, and delete portal row. In addition, a script used in onRecordCommit script trigger is needed to freeze the record in the gray zone we previously discussed. All the above is not new grounds. FileMaker developers have been writing about committing prevention for a lot of years. Some notable resources to follow up are FileMaker Transactions by Todd Geist, Deep Dive Scripting, and Audit Log, which was a DevCon session by Wim de Kort, and Modal Edit Dialogues with full rollback support by Artie Brosius. What about the edit though? This is the final piece missing from the whole process. The most popular technique is to start the edit process using the script trigger on layout enter. It is commonly used with a nice modal or card window where user can edit the record. That's a great solution because it gives clarity on when user edits the record, and it's commonly used in web-based systems. However, there are occasions where you want to avoid the extra click, the distraction, and the redundant layouts. My aim was to replicate the edit process exactly as FileMaker does it. Let's enable the built-in FileMaker layout save and see how the save cancel is handled by native FileMaker functionality. To enable the save cancel functionality built-in FileMaker, you need to navigate to a layout, go to Layout Mode, go to Layout Setup, and disable the Save Record Changes automatically. Click OK, go back to Browse Mode, and whenever you do a change, FileMaker will ask you whether you want to save changes to this record. Notice when the prompt comes up. This is when the record is edited. If user enters a field without making any changes, no prompt comes up. If a user creates some changes, moves to another field without committing the record, the prompt still doesn't come up. It comes up when user tries to commit. So, it comes down to a script trigger that doesn't exist. There is no on-record edit script trigger. How would you replicate this behavior in FileMaker with the ability to create a batch of edits and user selects when to save or cancel? This behavior is possible in FileMaker using Managed Security. There are some pros and cons when using Managed Security. The good are that there is system-wide control of save cancel. No script trigger is needed, works in every layout, it will not trigger in a full access account, making debugging easier, feels right, and feels like a desktop application. On the other hand, the bad is you need to add the prevention function in every privilege set and in every new table. Last but not least, the same pro is a con that it will not trigger in a full access account. This means if a full access account changes data, the functionality will be missing, including any other operations possibly included when saving. However, developing in a live environment is highly discouraged. So I assume you develop on a developer file and not in a live file. Let's sum this video up and continue by launching our job tracking solution. So, to demonstrate the Save Cancel transactional operation, I have created a Save Cancel add-on which includes all required pieces for this functionality to operate. To install the add-on, get the file savecancel.zip from the course resources. Unzip the file and move the folder to the appropriate add-on folder. If you are using a Mac, go to Finder Go and keeping the Option button pressed, select the library folder. Go to Application Support, FileMaker, Extensions, and then Add-on Modules. Now move the Save Cancel folder into the Add-on Modules folder. Quit FileMaker and launch back to your job tracking solution. Go View, Layout Mode, select the Add-ons tab in the leftmost panel, and click the plus button on the bottom left. Select the Save Cancel add-on, and that's it. This awesome functionality is now in your solution. Let's go through on what has been installed. Go to your custom functions, Manage, Custom Functions, where you will see a new function called Prevent Commit. Let's see what it does. First, it checks whether an object called recordSaveCancel.bb exists in the layout. Then, the function checks the version of the FileMaker platform it evaluates. In this particular setup, it will work on FileMaker Pro, FileMaker Go, FileMaker WebDirect by excluding the rest. As a side note, this code will also run in custom web publishing. I assume for custom PHP and custom XML, you will create a new privilege set, which is where you infuse the prevent commit custom function. At the end, there is some ready code to copy and paste in the managed security where the prevent commit occurs. Let's copy this code and paste it in the appropriate places. Go to File, Manage Security, Advanced Settings, and select or create a new privilege set. Note that you cannot apply this functionality in the default privilege sets. I will duplicate the data entry only privilege set and call it user default. Now select Custom Privileges in the Record Access section and paste your edit record code in every edit calculation formula section you need to. In this example, I will paste it in all tables. Next, do the same thing for deleting records. Last, set the default privilege settings to No, so if you forget to include the code in future tables, user will not be able to access data. Next, let's take a quick look in the scripts. Go to File, Manage Scripts. Note that a new folder has been added with the name of add-ons. Expand the folder and the added scripts are now revealed. The new record script uses the naming convention created by the templates developer and initializes the prevent commit before creating the new record. The delete record script prompts user to confirm, resets the prevent commit, and deletes the record. The close record is one script to use for both commit record and revert record. It checks whether the prevent commit is on, and if so, there are two modes: commit record and revert record. Delete portal row prompts user and initializes the prevent commit so user can cancel portal row deletion. Last but not least, on record commit is the script to use on record commit script trigger. It locks the record when prevent commit is on. Now let's go to a layout and test it out. I go to Stuff, click on a record, and this seems like a nice place to include save cancel functionality. Go to View, Layout Mode, and drag and drop the module in the layout. Below the button bar, there is a note to include the onRecordCommit script in the onRecordCommit script trigger. I included the note because I always forgot. Go to Layouts, Layout Setup, and select the onRecordCommit script for the onRecordCommit script trigger. Now, let's launch this file with a new user of that privilege set we created and test the functionality. Before this, I need to create the new user. Quit the file and relaunch with the new credentials. To test the functionality, navigate to the layout. I will now edit this record and test the functionality. When clicking outside the field, the on-record commit script trigger fires. As a result, our Cancel Save button bar is now appeared on the layout. By clicking on Cancel, there are two options. Click on Keep Edit if you wish to keep editing this record. Click on Revert if you wish to revert back to the last committed state. Click on Save if you need to save this modification. And this is how easy to include this awesome functionality in your own solution. In this chapter, we will explain what's an audit log and how it's being used. So what's an audit log? A security-relevant chronological record of events and changes. Events and changes may be a user created a new user with a specific privilege set, a user logged in, a user exported records, or a user accessed a record, or maybe a user edited a record or deleted a record. Another event could be a developer modified the database schema. Depending on the solution and the organization's needs, other aspects may need to be audited. The audit log audience are stakeholders that will potentially require to access information on the audit log. Those parties can be IT professionals checking solution usage, performance, and data integrity. Organization managers requesting information on who has access to what. Auditors of external bodies ensuring the organization compliance to an accreditation requirements. Users that need to view a record history or even roll back to a record's previous state. These are some examples of the stakeholders the audit log may need to address. What to audit? Logging everything can be expensive to maintain, enormous to manage, and possibly pointless. On every occasion, developers need to appropriately evaluate what's important to be logged and create a risk assessment on what's important to audit. This is the hazard analysis. In the following table, there are some examples of events. Which event would you say is most significant? User creates new record, user exports 1000 records, user deletes a record, user deletes 1000 records, or a user views a record. At first sight, one could say deleting 1000 records is the most hazardous event. However, from a lawyer's point of view, deleting 1000 records of a website that logs sensitive data of visitors can even be beneficial. In the same example, the most hazardous event would be a user exporting 1000 records and thus gaining physical access to sensitive data. The second event would be when a user views a record. In conclusion, the risk assessment is critical and depends on each case and point of view separately. Functionality options. A developer should obtain the requirements of the audit log functionality after appropriately assessing the case. Most frequent functionality options are audit log report, rollback event history, stakeholder report, and critical information for the developer. A solid audit log is key to achieve advanced security, compliance, and data integrity. It also builds a trust towards the stakeholders and their scope of interest. Auditing FileMaker events. So what of the above can be monitored in FileMaker using native functionality? The most critical information to keep logged are user sessions, when a user logs in and logs out, user management, when a user gains access to the database, data tracking, when a user viewed, created, edited, or deleted a record. Also, when a user exported records, or when FileMaker shared data with an external service and vice versa when an external service gained access to database data. Those events can be handled using script steps or script triggers such as on first window open and on last window close for sessions, a globalized script to add an account using the script step add account, transactional operations, which is the first part of this session, globalized script to export records to track the exported data, a globalized script using the insert from URL script step, and last, the FileMaker data API in conjunction with an audit log. This means that whenever FileMaker shares data, an audit log record occurs. In this chapter, I will present audit log tracking of the following events: new record, edit record, and delete record. I find these events to be the most useful from data perspective, and that is why I narrow it down to those three. At the end, I will demonstrate a data tracking audit log with a record rollback functionality. So what's the single most important issue in developing such an audit log? Every time a user manipulates data, a record is added in the audit log. Imagine the capacity needed for 100 users working on the database every day, one record for every creation, modification, or deletion they perform. It gets massive. That's why audit log payload needs to be as minimal as possible. So let's make a list of the necessary information in the audit log payload. Access info like account name and privilege set. Event info, script name, script parameter, timestamp in UTC format to avoid time zone issues. Data info, such as file, layout, and table information. Finally, records info. Regarding the records info, the challenge is how one eliminates redundancy. By investigating how progressive backups work, I concluded that the optimal method to capture field data would be new record includes all fields in payload, all record edits capture only modified fields, and deleting a record is only a state. And this is how the payload schema looks like. The records info is separated into field data for context record data and portal data for related records. I also include an underscore meta key in every record where you can find the primary key, the modification ID, the record ID, and the record state. This schema is intentionally as close as it could get to the payload returned by the script step execute FileMaker data API. This will become very handy if you already have JavaScript code to read data in this format. In its full version, I also include session ID, which is a unique identifier for every login, and the event ID, which is a unique identifier for the running event such as save record, delete record, etc. I omitted this info for now because in this session the aim is to focus on the data. That being said, let's discuss how to deliver the rollback functionality. So the issue here is that every edit does not include the whole record. This means that in order to roll back, we need to reconstruct the record to the selected state. So what I do in this given situation is get the initial record when it was first created, which includes all field data, and build up to the selected state. This operation is performance intensive, but it is accepted since eliminating redundancy is of highest importance. To implement this audit log functionality, you need the following key pieces: an unstored calculation c_audit_log, a custom function named getAuditLog, some other custom functions used primarily for parsing, audit log table to store the payload. The whole functionality is based on two functions: the getModifiedFields function, which rests within the unstored calculation, and the while function to loop through occurrences. This session will have updates, including an audit log add-on. For the moment, I have created a new version of the job tracking solution, including the audit log functionality. Let's wrap up the theory here and take a look in the new file. Here is a new version of the job tracking solution I created embedding the audit log functionality. Let's log in using the admin account and admin password. Go to File, Manage Database, and let's see what's under the hood in the unstored calculation. I will not go through the whole code, but I will just explain the logic. The calculation evaluates only when a record is not committed. This means that you will not compromise performance with this unstored calculation. The second part is that you need this calculation in every audited table in order to get the audit log for related records. Now let's make a modification and check the getAuditLog custom function. Before that, let me show you a cool trick to allow users to use the new record and delete record default FileMaker buttons. Go to File, Custom Menus, and here you see the default menu set for this file is Standard Copy. I will edit this menu, Edit Records, and for New Record, instead of the New Record command, I will select an action. The action will be Perform Script New Record. I will do the same for deleting a record by selecting the Delete Record script. Now, when user creates a new record or deletes a record, the scripts we created will perform. To create a new record and test the functionality, I need to log out and re-log in using the account name John and the password is 1234. I will go to Stuff and create a new record. Let's set a name, a last name, a title, and the phone number. I will also set a related record in the assigned tasks. Seems good. Now, before saving, let's see how the audit payload is constructed. Go to Data Viewer in the Tools section, log in using the admin account, password is admin, and check what the getAuditLog function looks like. I will also use the JSON format elements to better visualize the data. It's a beauty, isn't it? Includes the data we previously discussed, and its schema supports multiple related records from multiple related tables. Let's add another task and see the result. Adding a new record, and before saving, I will go to Data Viewer and see the payload again. As you can see here, the portal data for the table staff_task has two records. The one record is send email to HR and the second record is contact client. Now let's save the record and go to the audit log to see what has happened. Let's go to the audit log. Here we got the timestamp, the table, the user, the privilege set, the state of the record, the script, the parameter, and the modification ID. Here there is an icon indicating whether there are related records. In this popover, you can see the entire payload of the audit log function. Now, let's go back to our record and create some modifications. I will change the phone number to something very simple you can identify easy. Saving the record, and say you want to restore this record into a previous data state. Click on this button, and here is the record's time machine. Here you can see the last modification I saved. By navigating back, you can go into a record's previous state. The upper part refers to the context record and the below part refers to the related records. Here you can see the state of the current record, the layout, the account, and the audit log payload. Below, you can view the related records created or modified with this event. Here is the state of the related record, and here you can see how many related records were created or modified in the staff_task table. Also, by clicking on this button, you can navigate through the related records of that table. If related records exist from more than one related tables, this section will include tabs for those related tables. I can also click on this restoration button to check the data that will be restored. Let's click Restore, OK, and boom! Record is restored. Isn't it awesome? Let's enter Time Machine again and see what's happened. As you can see, the only fields that were restored were the phone and the timestamps. That's because the script is checking whether it needs to restore a field. Let's try now adding an address. I will save this record and enter the Time Machine. Here you can see the address we just entered. I will go back to its previous state and restore. The address is now gone. Let's do a last test and delete this record. When clicking on delete, thanks to the custom menu mod we did, delete record runs the delete record script. The delete record script logs the record deletion in the audit log. Let's go to the audit log. And indeed, I can see the event right here. Now, let's enter the Time Machine and restore this record. Here you can see the state is deleted. I will go back one modification and restore to that. Boom! Here is my record back. As we explained earlier, this functionality requires full record history of the record since its creation. This is why restoring the template records is not possible. A final note is that in this current setup, I have not included restoring related records. As shown in the audit log payload, the data exists, and depending on the data model, it can be implemented restoring related records. This session will have future updates, including an add-on of this functionality, so you can drag and drop in your own solution. Retrospectrum. In this session, I examined the integral parts of a record commit and broke it down into 4 events: new record, close record, delete record, and delete portal row. I showcased how to globalize script steps by embedding them in scripts and explained why this technique can produce powerful results. Next, I demonstrated how to add the Save Cancel add-on to deliver transactional edits to existing layouts in your solutions. I then added the audit log operation in the record save and delete events to audit record data. In the end, I demonstrated one of the functionalities you can provide to your users using the audit log. The rollback functionality is just a cool beginning on what an audit log delivers. A solid audit log is key to achieve advanced security, compliance, and data integrity. Additionally, it builds a fundamental trust towards the system. All files are included in the session's resources, and there will be an update with the audit log add-on. Thank you for your time.